Okay, my friends, I am here to tell you that the Higgs boson is completely misunderstood, and I will explain to you why I can make that statement. They are hitting gigantic, enormous globs of material head-on and seeing all these fields and then saying, wow, we just found a Higgs field. Let me show you what they did find and then show you what we did find. Okay, my friends, like I said, they smash gigantic particles together and they get this debris and they see these spinning fields and they say those are Higgs bosons. Computer simulation particle traces from the Large Hadron Collider in which a Higgs boson is produced. Well, let me show you what we found in our Higgs bosons. Now, that's the model. And they say the Higgs is where all the mass comes from. Well, no, the Higgs is when the mass comes back together. They think this particle makes all these other particles. These two particles, when they come together, make the Higgs. I'll show you that happening right now, and then I'll show you what they did at CERN. Okay, these are the Higgs from CERN. These are the Higgs from CERN. Gigantic particles, just nothing but trash. We used light, and when it came through, the white reattached to the black and turned into the Higgs fields. You see the Higgs fields here? That's a Higgs field. When did I show you that thing? These are Higgs fields. Let me just show you what happens. You take the light, and you accelerate the light, and it's just starting to accelerate now, so we're seeing it start to glow up. And as it pushes through all the particles in the air, electrons to electrons create glow. That's just energy. Mass is pushing one thing against another. Now, watch what happens as we get forward here. Look at this. That white shower coming through our Venturi came back together with the black particles and turned into the Higgs. It's not the other way around. It's not the Higgs turning in to the other particles. It's the other particles turning into the Higgs, which settle down into light particles, really. You see this? Observation of a new particle, which is the Higgs, with a mass of 125 giga, that's billions, electron volts. Here's what they say right here. This is the new particle they found. Event recorded with the CERN detector in 2012, proton, center of mass gave them 8 trillion electron volts. It shows the expected decay of the Higgs, a decay of a Higgs to a pair of photons. Well, the pair of photons make the Higgs. It's not the other way around. The event could also be due to known standard model background processes. Well, it's not what they think it is, let's put it that way. They don't understand the Higgs boson. They're exactly backwards. They say the Higgs boson decays to those other two particles. Those other two particles make a Higgs boson. Those other two particles attach to each other, creating the Higgs boson. You see this? There's the Higgs. That's that big field. This is a W and a Z boson. Those are the white and the black particles. Now watch what happens to create this Higgs, which is that big fluffy field I showed you. All right, this is what a Higgs looks like. That's a Higgs field. This is the Higgs field right from Fermilab or CERN, whoever made that little doodle. And they're using full spectrum light protons. So they're getting all these different colors. We're using coherent light, one color. So we get basically one color, you see, the red. But we accelerated it through the Venturi and separated the two bosons apart, the white and the black. However, when we separated them, here's what they normally look like. Now see the white and the black together? That's a photon. This is a neutrino. It's not yet a complete photon, and that is also a neutrino. Neutrino, photon. What happens is as they stack up against themselves, they increase more and more mass, so you get different flavors, they call it, of neutrinos. That's what that's all about. When this hits the Venturi, they break apart because only the white can get through. And we did the same thing with green. Here's the green, same thing. Here's the neutrinos. Here's the green particle. No, there's no difference whatsoever. It's just much faster, much faster. I think I got something. Here it is right here. well, when I say faster, it spins faster. Now, is it actually faster? I don't know. They would say no. I'll go along with that. I don't know. I can't prove it one way or the other. But I can tell you one thing. That red is just getting pushed out of the way, and the green is reconcussing out here. And it spins, and it's much more powerful. You see how dim that is compared to that? And you see this is just pushing that out of the way. It's making them actually spin this way. They never, ever, ever, ever do that. They spin like this. This is spinning like this. Normally they spin like this going down, polarized towards the Earth. This is tumbling over. That's unheard of. In my world, I haven't seen it before. They're normally like this. They don't tumble. And the same thing with the green. The green's going on an angle, but it's not tumbling. You see it? It's facing straight up to the Earth, even though it ends up going this way. The polarity of it is towards the Earth because it's a magnet. It's a bar magnet. Earth is nothing more than a sucker of electrons. All electricity goes directly to the Earth. The electron portion goes straight down. Can't stop it. Electricity, lightning, static, right to ground. Now, these are the kind of things we're going to be going through about matter and light. What is it made of? What is a field? What is a wave? What's a quantum field? Can we visualize these things? What about Feynman, who came up with all these diagrams? He didn't understand what he was talking about, but he knew he could see these events occurring. He had no clue why. And that's because they were using these gigantic particles, and all they were seeing was debris. Virtual particles. Well, how do you use Feynman diagrams? Quantum electrodynamics. What is its purpose? Do particles exist? They don't even know if particles exist. I'm not kidding you. Right now, it's just totally, they're totally out to lunch. Nobody knows, and nobody wants to investigate what's right in front of their face. I've been pushing this on everybody in that field, and I'm pretty pushy, and they know about me. I know there's no question about that. Now they're starting to talk about it, like sort of nibbling away at the edges, but let's just get right to the meat. Let's just go right for the inside. Don't forget, they really haven't found any of this stuff. All of this is theoretical. They're showing things that just is in a pile of debris, saying this must be this must be these. These are an elementary zoo. They're not. They're two particles, and they are the smallest ones that exist. And I show them in light of all the different colors. Now, here they're talking about other bosons looking beyond the standard model. The standard model does not work exactly correct. Very close, but not exact. We might find the Higgs boson different from the simplest versions of the standard model predicts. Many theories that describe physics beyond the standard model, such as supersymmetry and compositeness models, suggest the existence of a zoo of new particles. No, it's only two, including different kinds of Higgs bosons. CMS, which is CERN, is a general purpose detector. It really doesn't do much other than smash, like crashing into explosions. It means not only design with particular hypotheses, but also with the aim to study whatever happens when you smash the hell out of things at high energies, even if the results are like nothing we expected. And they are nothing they expected because they don't understand the makeup of that nucleus. If unexpected phenomena do occur, we are looking for them. No, they are not. They are avoiding them with every bit they can possibly avoid. It seems we are looking at just the visible tip of an iceberg. Yes, you're not even looking. That's why. Hidden below the standard model must be a deeper, more fundamental theory gives reason to what we see on the surface. Let me show you what you see on the surface, and I can explain what must cause it. All right, don't forget now, they're saying these are their Higgs bosons. Higgs bosons. This is from CERN. All right, and because they're using all different colored particles, they're using big particles so that they get the different colors. We're using coherent light, red, green, blue, that's all. See, red, green, blue. We're not using the multicolored particles like they're using. They're using just gigantic things so they get all these different colors. Now, I am showing Higgs fields. Higgs fields. This was a very unusual Higgs field, and it did change a color. You see that? These are red coming through. And this one got pinched and turned it blue. That was the first time I've ever seen that. Because they should stay red. They all came through red. They started like this. When they go through the Venturi, they turn white, but then they turn red again. You see here? Look. They come through here. They break the white off of the black off of the white. The white comes through, and now we're looking straight into here, and we see those Higgs fields start to occur as the white adheres back to the black. It's not the other way around. They say the Higgs field creates the W and the Z boson, which is the white and the black. Totally the opposite. The white and the black, when they smack back together, they create the Higgs, which is that spinning disk, which has not only the white, but it has the black built into it as well. Let's take it one more time. The laser's going straight through this way. The Venturi is here. It's just a tiny little slit, and all they can get through is the white. The black balls will go around, and the white, though, will find some more black over here to attach to. There has to be extra black just laying around as far as I'm concerned. But what happens is you'll see the Higgs fields here, and that is due to the fact that the black is now coming back into the white. And so it's totally opposite to what they're saying. And here's what happens is when that white comes through here, the black starts to attach to it and starts spinning into that standard disk again, which is the Higgs field, but it's the photon. All right, it's both the black and the white together. And here it comes through on steroids. You see this? This is that white stuff coming through, and boom. This is what's created. These are Higgs fields. That's the white separated by itself coming this way. The only thing I can tell you is the white was by itself, and the black is normally attached to it. The black is now back attaching back to the white. So that's the process. It's not that the Higgs fields turn into the black and the white. No, totally opposite. Now you see this? This is what they see in outer space. They're seeing a black particle and a white particle interacting with each other, causing gravity waves. That's the same thing as our Higgs fields created by smashing those particles. This is very interesting, the black particle and the white particle. We see these, we know they're there, and they create these fields. Let me show you what we did see in space. You see that? This was taken with a regular cell phone. These are the fields that surround the particles. There's the black and the white. These are the Higgs fields. They're magnetic fields. That's all they are, is magnetic fields. And when things bang into them, they bang into them, just like light particles bang into magnetic fields in space. Space is saturated with these fields, saturated. Light slows down as it comes to us. They totally disregard that. You see that? These are nothing more than fields. Every one of these lines is a field. It's a magnetic field. Push to shove, push to shove, push to shove. And wherever the most intense part of the field is, the lines are closer and closer because it's push, pop, 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 pop. That's it. That's the way all these, but every one of these is a dipole. You see the black and white, black and white, black and white, black and white. That's just the nature of all particles in space that are spinning. If they're spinning, they will become a dipole. The moon is not spinning. There's no magnetic field around the moon. This field here is produced by some other particle out there, some other whatever's out there. But it's not the moon. The moon itself has no field. It's moving that way, crushing light in front of it, turning it blue. But it is not spinning to create a field. The spin creates the field because one particle, one orb, has all glued on electrons to it. As it spins through the other electrons that are in space, it creates these fields, just like an electric motor does, exactly identical. And so they're totally backwards on the Higgs field. Now this is the one that's crazy. Remember the light coming straight at us. Originally it's only white. There is nothing in here, so you don't see anything. You see the little white spritzes. But that's all you see. They haven't reattached to the black yet. Here's where they're making their reattachments, which is coming out at us. Bam, 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 bam. So the center core is still white out here. But around the edges, they're filtering in and reattaching and they're catching on to a black particle and showing these fields. Now look at this one. That one right there is spinning backwards. I'm almost certain of that. You see the trail it's leaving? Hooking off to the left. I think that's spinning, which is a left-hand spin. It's supposed to be a right-hand spin. They're supposed to be coming out this way, right hand. If it went backwards, I think it's drawing its field into itself. They're supposed to be spinning their field out, splaying it out. That one there is sucking it back in. And watch what happened when it interacted with another one of these Higgs. This is what I find fascinating. Don't forget, the laser's coming at us right here. This is all whiteness in here. I'll show you in a second. Make more sense. And all the way around here and all the way out to here, the black particles are trying to come in and grab a hold of all this whiteness. We're seeing nothing here because it's nothing more than whiteness. But now look at this. What I'm going to show you right here is the whiteness that we can't see, because and there it is right here. All right, so we're looking into all this whiteness. All the blacks are coming around the edges trying to hook back in again. See them, all the ones here? All the black ones are coming here all the way around the edge. We were looking into the whiteness. Now, don't forget about that one particle. That's the key. Here's the one particle that is the mind blower. All right, all that white coming at us. That one here spinning backwards. And here's what happened when it connected with one of the standard Higgs fields. That right there. That particle should be like this. All right. What happened is these disks are spinning like crazy. That's my interpretation. These disks are spinning like crazy. Now, this one was spinning backwards, and this one was spinning forwards. So this one's going this way. They all should be going in the same direction, and they sort of just tangle in with each other and roll down the road. This one is backwards. When it hit this field stripped this edge off. Normally they'll just sort of bump into each other and lay up against each other, and they're all spinning in the same direction, so there's no big deal. This one unwound the reverse field. That's the way I'm seeing this, because this is the only time I've ever seen this. Very, very, very unusual. You see how they all bunch together? Nobody's fighting each other. Nobody's throwing a field off backwards. They're all just sort of rolling together the same way. Well, these are all rolling this way, and one of them's going that way, and it ripped a piece right off it. That's the way I'm taking this. Now, I could be wrong, but that's about the most unusual one I've ever seen. And anytime you see glow of white, that is high energy. This is high energy. So what is happening? This particle here, this one is rolling in this direction, the bottom one. This one's going in this direction. They touch here. It grabs and zip, ripped it right off. That's why the high energy is here, and it's spinning backwards over here. Very, very unusual. That's got to be an anti-particle, antimatter, something. You see this? We're using electron showers, and this is the physics for doing it. What we want to create is neutrinos in all the different flavors, which ends up giving us electrons and muons. And then we can get up to 100 gigavolts to a few trillion electron volts. And that is exactly what we did. We created those two particles they just talked about. Where are we here? All right, these are the two particles right here, the muon and the electron neutrino. All right, and the black ball went this way, and the electron showered. I showed you, it says electron showers. This is what we're trying to create, and we did. And they should have these kind of excessive, enormous amounts of voltage. And as far as I'm concerned, if we can do this, which we did, accelerate, split the particles, that's fission, that's fusion. This is raw energy, and I don't see any reason we can't use that. If they're right about the multiple billions of electron volts, up to trillions, it only takes a couple of million electron volts to do this. If we're in the billions, that's an absolutely enormous increase in energy. If we can use that increased energy to create electricity, why not do that? I think that'd be a good idea. Something you carry around in your hand. And it's totally off the grid. It would look just about like this. You carry this thing around with you, plug anything you want into it, AC, DC, 60 volt, 60 cycles, 60, 50 cycles, whatever you want. And watertight, just carry it around and just keep running forever. There's no reason you should ever have to stop this from running. This should be able to power cars, houses, lights, power equipment, water supplies, boats, outer space. I don't care where you go with it. All right, because it's just going to run by itself. If this is right, will this work? I don't know. But if they're correct about their energies creating electron showers, that's what we got, electron showers. Hundreds of gigavolts, which is billions, to a few trillions. Electron showers. This is what the key is. Now, they never could do this because they're using protons. We're using light, which is basically electrons already. They're two electrons back to back. They call them gluons. And here they are right here. This is what the standard model is. These two together make an electron. They call it a gluon. So these two glued together, they call a gluon. Two gluons make a photon. That's it. These two together, when they come back together, they show that big Higgs field. The Higgs field is not producing this. The Higgs field is produced by the interaction of these particles creating that big field effect. And that's exactly what it is. Everything else here is made of these two particles in various phases of energy. The neutrinos stack up energy more and more. All these other things are just spinning up top or spinning underneath and that sort of stuff. And then every now and then they see some of them rolling. They call them charm and love, and I don't know, they got all kinds of names. All right, so for the next presentation, we're going to go through every one of these, and we're just going to take them one at a time and lay it right out exactly what it is, and then we're going to have interaction between everybody. If you have a question, let's talk about it. I think I can show this stuff pretty well. See, they're showing this. This is not my picture. This is, I believe, from CERN. This is gravity waves, where they're pushing and shoving to each other, white to black. Precisely what I am showing in our particles, or our space here. This is the same stuff. You see all those fields around, and all of these are dipoles, black and white. Space is loaded with slowing down particles. Every light particle coming through this maze of particles and fields is slowing down. Depending upon where you are in the universe, on the arm of the Milky Way, we may be going through denser space now or lighter space, and that will affect our weather patterns. It's a scrubbing effect of us going through what's ever in front of us. And the bigger we make our envelope of gases, which is the CO2, I agree, it's pumping up our envelope of gases so big that we're scrubbing much, much harder than we normally would. If we get rid of some of those gases, yes. But just getting carbon out, I guess carbon in its solid form, that's fine. You got to take it out of the gaseous form, that's all. You see this? In the standard model, the Higgs particle is massive, yes, because it's interacting, smashing together, causing those big fields. That's the only mass that it has other than normal. They're saying it has no electric charge. I disagree with that. No color charge. Disagree with that. It couples together to interact with mass. Well, they have it backwards. You see what it says? It is also very unstable. The Higgs is not unstable. It says it decays into other particles almost immediately upon generation. Absolutely opposite. The two other particles join together to create the Higgs. They're seeing it smash into bits. And well, they're probably seeing it come back together and thinking it was smashed into bits. That's what they're doing. I can almost see it now. Now, don't forget, I'm getting pretty deep into this now. These are the muons, the black balls. These are the electron white ball showers. And these are where you get the extreme energy showers coming up here, high energy showers, where I have that white particles here, coming here. It's coming through the Venturi. Back here, you're going to have a hell of a lot of energy, high energy showers. The muons stack up here and they stay back. See, they're showing them banging up here, way out here. The white gets squirted through. It's exactly correct. The muons have earlier shower maximum. They collide here and they stay back there. Because we got a Venturi that won't allow the black ones to get through. We only allow the white ones to get through. All right. They are showing the same sort of interaction with, but they're hitting tungsten so that they drive it off from protons. We're using light and light only. They're using light to crash into tungsten, which is not light. It's atomic particles. They're doing basically the same thing we're doing. They're shooting high energy particles, but they're hitting tungsten. Now we're hitting light. We're just using light through the Venturi, as I showed you. This is nothing more than light, and this is nothing more than a very cheap Venturi. It squeezes the light together and forces the fields to interact in such a way that it keeps the black from following the white. Very elegant way of doing it. And again, we have a hell of a lot of energy, high energy showers coming through there. These are the white electron showers. These are, see, electrons. These are the muons, and they stay on the other side. Okay, here's another thing totally wrong. Genes don't lie. DNA reveals a new twist in human origin story. Yes, I've shown that in my mud fossils. So now they're starting to look into this a little deeper. This entangled photons, that's just insanity. They will never come back to being from the photon they started from. They think they're entangled and they want to come back to be with their partner. No, they're just going to find a new partner when they come back out of the other side of the Venturi.